Today we're doing Module 5, Lesson 12. And today we're going to measure, we're going to use measuring tools. What's a measuring tool called? A ruler. Good. We're going to use rulers to measure to help us find the area of rectangles. And we're going to be using area models to help us find the area. We've used area models before in the past, but it's been a while. Okay? Today when I show you it, hopefully you're like, oh yeah, that's what that is. Okay? Let's first talk about the problem of the day. What is this measurement right here? Is it a mixed number? No. There's only a whole number part. It's 2, right? Which means we don't have to split it. What's this measurement right here? 2.5. Is there a whole number part and a fraction part? Yes. How can we split it apart so that we have a whole number part and a fraction part? Well, we could split it like this, and we can say from here to here is 2, and from here to here is 1/2. Do you guys agree? Whenever we use the area model, we are finding partial products. We're finding the different we're splitting it up into smaller sections in order to find partial products. In this case, we're splitting 2.5 into 2 and 1/2. And then we're going to find each individual area before we add them up to find the total area. Does that make sense? How do I find the area of this blue section? Well, I do the length times the width, or the length times the width, right? Which is 2 times 2. Which is 4, what kind of inches? 4 square inches, good. How can I find the area of the green part? 1/2 times, good, so write that down, 1/2 times 2. What's 1/2 times 2? 1 square inch. How do I now find the total area of the entire rectangle A? Well, I have to add the partial products. 4 plus 1 equals 5 square inches. In the directions, does it tell us to find the area just by multiplying the length and the width? No. It tells us to use a specific strategy. What strategy are we using? Area model. Whenever we do the area model, we're splitting our big rectangle up into smaller rectangles, and then we add them up to find the total area. Remember doing this before? Good. The only difference today is that we're measuring to find the measurements, the length and the width. If I wanted to find the area using multiplication, I could multiply 2.5 times 2. What's 2.5 times 2? 5. Is that the same area we got? Good. Using your ruler, what did you find the length from here to here across the top to be in inches to the nearest 1/4 inch? Tarun? 1 3/4 inches. Thumbs up if you agree. Okay, 1 3/4 inches. Very good. What about the height, or the width, I should say, not height, the width, from here, to the nearest 1/4 inch. Luke? 1 3/4 inches. Thumbs up if you agree. 1 3/4 inches. Very good. Now, we need to find the area using an area model. So let's take a look at each measurement. 1 3/4. Can we split that up into a whole number part and a fraction part? Yes. What would the whole number part be? 1. Okay, so from here to here we would say is 1. And the fraction part would be? 3/4, because 1 plus 3/4 equals 1 3/4. How come I'm writing the measurements down here at the bottom when 1 3/4 is at the top? How come I'm saying from here to here is 1 at the bottom when actually the 1 is up here at the top? How does that work? And how come I'm saying 3/4 is down here at the bottom from here to here when really the 3/4 is up here? Why am I doing that? And is that okay that I'm doing that? Talk to your partner about why that works. Let's talk about the other measurement. I have 1 3/4 again. How can I break that up into a whole number part and a fraction part? Priya? 1. Good. So I can say from here to here is 1, or from here to here is 1, right? And then from here to here is 3/4, or from here to here is 3/4. Do you guys see that? Okay. Now, does that automatically mean I have the area? I have to find the partial products, or the partial areas. How many partial areas will I have to find? 4. 4. Very good. Okay, let's find this first one here. In red, what are the dimensions? What is it from here to here? 1 inch. 1 inch, because it's here. Good. What's one from here to here? 1 inch. 1 inch. So how do I find the area of this red portion? 1 times 1, which is? 1 square inch. Very good, square inch. Okay, now I would love to find the area of this black part right here. What's this measurement? What's this measurement? Good, because it's the same as down here. So how do I find the area? 1 times 3/4, which is? Good. This is kind of like when we were doing the tiling. We could use a full square inch here, but here we'd have to cut 1 into 3/4. Do you see that? What about down here? How do I find the area of this part? Well, I have, what's this measurement here? 3/4 times? Good. So 3/4 times 1 is? Square inches. Good. And now this, again, like the tiling, right? I would have to cut my Post-it into 3/4 of a Post-it. Down here, how do I find the area of this last green section? Oh, good. What does that equal? Good. I'm going to write it over here. Equals 9/16. Don't forget how to multiply fractions, right? We multiply the numerators and we multiply the denominators. Don't get confused. Okay, now how do I find the entire area of the entire rectangle? Well, I have to add up my partial products. 1 plus 3/4 plus 3/4 plus 9/16 square inches, right? Go ahead and do that. So I have 1 plus 3/4 plus 3/4 plus 9/16. Am I ready to add? No, my denominators are not the same. I have a denominator of 4, a 4, and a 16. What's the least common denominator? Okay, so let's rewrite it. 1 still stays the same. Instead of 3/4, how many 16ths is that?
12.
Because I have to do 4 times 4, which is 16. So I'm going to multiply it by what version of 4? I mean, what version of 1? 4/4. So what's 3 times 4?
12.
Okay, so this 3/4 is also 12/16. And then I have 9/16. Before we go on, please explain to your partner how we went from 3/4 to 12/16. Go. How many holes are there in 33/16?
2.
So this is 1 plus 2 and?
1/16.
So the final answer is?
3/16 square inches.
3 and 1/16 square inches. Good. Write that over. Good. Okay. Now that we know that she doesn't need, the part that she doesn't need carpet for is 6 1/4 square feet, could I find how much the entire square is and then take away this part? How do I find out how much the entire square is?
16.5 times 16.
Yeah, I would take the length of the room, 16.5, multiply it by the width of the room, which is 16.5. Okay, once I find that, I would then take away 6 1/4. Do you agree? Very good. We're not going to actually solve that right now, but it's important that you understand the concept of how we could find the entire square. Joseph, please pay attention. How we could find the entire square and then take away the part that we don't need, which is 6 1/4 feet. Yes? Do you guys agree? Good. You'll have a chance to solve a problem just like this in your problem set